Welcome everyone to the next episode of AI Cloud Horizons, where we sit down with pioneers leading the charge of AI and enterprise AI adoption. My name is Navarre Pratt. I'm a software engineer on our applied training team, and I'm joined here today by Belgodere from IBM, who I've had the joy of working with throughout pretty much this entire year. A project of bringing up one of the first and one of the largest GB200 NVL72 based clusters online, and working with the IBM team to build out what we'll be talking about today, the Granite 4 model family. Brian, thank you for being here today.
Thanks for having me.
Before we get into GB200 and Granite 4, let's set the stage for what enterprises are dealing with today adopting AI, whether it's deploying it themselves, adopting AI-powered products. What are some issues they're running into, and what are they trying to get done today?
So I'm a senior technical staff member at IBM Research. I've now been there going on my 15th year, which is very insane to say. But our group is responsible for designing, deploying, and managing all of the compute for research and the thousands of researchers we support and the varied workloads we support, from quantum to chip development to AI. I've been working on accelerated computing, deep learning since 2016. So I've seen the incredible ramp up in demand for compute. And we've been building large GPU clusters internally. We've built them in cloud environments with partners. We've done a little bit of everything. And as we started to announce the Granite family of models back in the end of 2023, we had already been working on these models for over a year. And we knew we just needed more and more capacity, given the early wins we were having with both customers. The models were performing in incredible fashion, and these early wins really dictated that we needed more compute and we needed to scale quickly. So that was actually my first introduction to CoreWeave. While we were deciding that we were going to build out our own large H100 cluster, we reached out to try to acquire some temporary compute capacity to bridge us through. But at that point, that's when we were all bottlenecked by the long lead times for InfiniBand switches and the dual port and single port transceivers. And it didn't work out the timing wise, but it was just a good introduction. So we ended up partnering with Dell and NVIDIA and built out a significantly large H100 cluster ourselves. But we had to do it from scratch. We didn't have the power and cooling capacity in any of our data centers. So we needed to go find a new data center and basically stand up this cluster from scratch. You needed system monitoring, environmental monitoring, security, hardening, all these things that you need to do if you're going at it alone. And that's before you even train a single model, and before you even get to that point, you need to deal with all the data. How do you acquire the data to train these models? And these are huge tasks, and I've seen the Herculean effort that we've done in research to provide, transparency into every token that has been seen by our models. This is not a simple task that any organization, well, we're just going to get some data. You need to be able to say what data has gone into train the model, what has not gone into train the model. As the legal and regulatory frameworks are constantly evolving, companies are concerned about what models they're using. Then once you have the data, you have the infrastructure that can train the model, you've gone through, you have the expertise and talent to actually train the model, you get good results. Then you have to deploy it, maintain it, run it, and support it in a life cycle that is not a simple process.
Yeah, a lot of our conversations with our customers start in the same way, right? Yeah. We need more GPUs.
Yep.
Okay, we could help you build some GPUs, but there's a lot more complexities that you start dealing with, like security, data protection. You could imagine that the data that these companies are training on is very protected. Right? They potentially pay a lot of money to acquire this data. They do a lot of work to acquire this data, and that's part of the secret sauce. Yep. So we take that security posture very seriously at CoreWeave, just like your requirements running on-prem.
Absolutely, and it's been great dovetailing our internal security processes right into CoreWeave's environment so that we can have a seamless view across all of our clusters. But going back to the proprietariness of the data that goes into these models, that's often one of the things that concerns companies the most. They don't know what's inside the model unless a company has been very open and transparent about what goes into them. So we have gone completely the other way. The majority of our data sets comes from Common Crawl. So we release the recipes that we use to process Common Crawl called NiceWeb, and we've put them out there in the open. We publish all the data sets that go into training the Granite 4 models. If you use the Granite 4 models on watsonx.ai, we actually indemnify the use of it. So we stand with full confidence behind everything that we have put into the Granite family of models.
So you and your team, as you've talked about, have a lot of experience standing up and running an H100 cluster on-prem. You've built this stack, you've built this expertise. Why did you take the leap into GB200, and why did you take the leap into partnering with a cloud provider like CoreWeave?
So it's a very, I'm sure we can go deep into this, but taking a step back, as again, we kept on seeing the more and more need for compute. So as soon as GB200 was announced, we're like, okay, wow, almost a 2x improvement theoretically. At the time when it was announced, we initially thought about building out our own GB200 cluster. We met with partners, we saw what NVIDIA's design was going to look like, what some of the Dell's design was going to look like, and then we started figuring out, where are we going to put it? You need a data center that has enough water cooling, that has enough power, and that they weren't in high availability, and everybody was coming after them, so they had significantly premium rates, and they wanted you to sign right away. Even if the hardware was not going to be there for 12 months, they needed you to sign the lease now, and they wanted you to sign a 10-year lease. So at that point, we started looking at, realistically, what would the cost of going with a partner be? And by dumb luck, my VP and I got invited to a meeting with CoreWeave at GTC, and we ended up having a great, deep technical conversation. We said, okay, maybe this is a possibility, and it honestly was not something we were looking at originally. And the more and more conversations we had with CoreWeave and all the folks there, the storage team, the networking team, we felt comfortable that we would get the GB200 into the hands of researchers faster with you than if we had gone at it alone.
Yeah, I think it's something that we talk a lot about internally at CoreWeave is you want research to move as fast as innovation, as fast as the researchers. But infrastructure can be a speed limit on that. And we just never want to be the blocker, using a term that you hear a lot in tech. You touched on a few different pieces there in data center design. There's the power density, and that almost forces you to go towards water cooling. Right? And there's different tiers of data centers out there. Even if you were on a top tier data center that you have tons of CPU nodes in, even if you have HGX-based systems like H100, H200, all of our GB200 builds are all liquid cooled because of that power density, and they're all in net new regions. So every new region, we're all standardizing around liquid cooling, again, because we're looking forward into the future. And I think that's what partnering with a cloud provider like CoreWeave can really do for you. We'll get into it later on, but there's a lot more compute flexibility we have using other nodes as we scale up.
Yep. And it was actually really nice to work with you because you were able to get us access to the GH200s so that we can validate our code, our builds, everything before the GB200s were available for us.
Yeah, so let's get into that story a little bit, right? This was end of 2024, IBM and CoreWeave started having conversations with each other. And there's a few things that we do, regardless of if the contract is signed or if we know it's going to be signed, we do with all of our GB200 customers that we started doing with IBM first, again, because you guys were our first GB200 cluster at scale. One of them, like you mentioned, is GH200 nodes. The Grace platform, right, is an ARM-based CPU. Anyone who's worked with ML researchers and compiling Python-based, ML-based images and libraries know that it's a big pain. So now recompiling everything to be multi-arch and building for ARM is something that some people have been caught where they start running on GB200 and oh crap, they realize I'm not ready for ARM. So we're able to get you guys access to a cluster for some GH200s for testing some things out there. And also CoreWeave's cloud platform as a whole is new to you guys, right? So that comes with learning how to use our observability stack, learning the node lifecycle, learning mission control, learning Slurm on Kubernetes. Previously, I believe that Blue Vela, these internal clusters, were using LSF.
Correct.
So you have to get used to using Slurm, which is like a researcher challenge to educate them. And then we have to get used to using Slurm on Kubernetes, which is where some of our networking security, data security comes in. So we did all of this, right, working with you and your team before we ever came close to the GB200s, before NVIDIA shipped them over.
And it's been nice because since we've managed the whole outside of Slurm piece, to our researchers, it's just another compute cluster that they see. They log into a login node, they submit their large training jobs, and they do what they do every day, and we get out of their way. I don't know if out of their way, because we still work hand in hand for all the small issues, but at least they don't have to deal with that concern.
Yeah, it's an interesting duality, right? Because you want to, as the infrastructure team, as the compute provider, be out of their way. but I think that we've shown throughout this project in GB200 that working full stack end to end with the researchers makes a huge difference in how quick you're able to move and how fast you're able to solve problems. But let's start with, we've onboarded you guys in the early days. You're used to Sunk, you're used to H100, cool, right? That's the baseline. That's what you guys were used to with your internal clusters. Here come the GB200s. And we had a sprint to MLPerf. You saw our record-setting MLPerf run. This was done with the IBM team on the IBM cluster in partnership with NVIDIA. And you could go and look at the numbers and see, biggest GB200 submission, obviously fastest because the GB200s are much more performant. How was that like working in the early days, getting this cluster online as quick as possible?
Oh, it was, I was honestly amazed at the amount of compute you were able to deliver in the beginning before we'd really gotten a chance to touch any of these systems. On both sides, we were like, okay, this is what we're hoping will happen, but we also had some healthy concerns of, well, what happens if it doesn't? We don't get this. But you guys moved heaven and earth to deliver the amount of racks that we were able to do. And yes, it delayed getting our researchers on the cluster by 10 days, about. But the amount of time that we saved from all the learnings of pushing these models to their limit for this benchmark more than made up for in the end time of delivering the Granite 4 models.
Yeah, I think those are some of the most exciting times or exciting memories I've had at CoreWeave. I was around for the H100 build out and our big MLPerf submission then, back earlier in 2023, and it's super excited. There's so much energy, and I think we felt that on both sides, IBM and CoreWeave and NVIDIA, of course. So let's break this down into a few different layers. There's the compute itself, right? We obviously have to rack and stack it, and there's all the data center techs putting it together online. Then there's the compute orchestration, right? CoreWeave has to burn it in, upgrade the firmware, run our own comprehensive health checking, which is not just node, but now at rack level to stress test the full NVL72 domain. And we have to move that into your cluster. And then finally, we have to run jobs on them through Slurm and then optimize that code, which you've alluded to, that we work closely with NVIDIA. So part of that early delivery, right, NVIDIA is putting out new versions of firmwares, fixing bugs. We're working very closely with them, again, before IBM ever gets their hands on these nodes. So this is all happening internally. The big innovation from CoreWeave there, as you can imagine, is switching from a node-based delivery system to a rack-based delivery system. So that's more than just booting nodes online or offline into different Kubernetes clusters. We have all of our health checking running at the rack scale now. If one node fails, we don't want to push the other nodes through success, and we do want to run rack scale testing. So there's a lot of early collaboration there. There's a lot of figuring out, okay, what is the all reduce nickel test bandwidth? What should it be?
What was the speed of light that we needed to
what
chase?
is the speed of light to throw a Jensen term in
Yeah.
there? So cool. CoreWeave is working with NVIDIA to get all these out there, and we start flooding your cluster with racks. I think it was every day, every week, we're getting new racks online. How was it running Slurm jobs on these GB200s? How was it working with the NVIDIA team? What sort of issues did we run to at first, and what problems did we solve?
I think the best value out of that collaboration was what we got at the end of it was, okay, we know these are sane settings that will work and push these systems to the limit. So I think we finished up, the submission was a Friday afternoon. We left a little work over the weekend just in case they wanted to double check anything. And then Monday morning, our researchers were boarded, and we were, based off all the findings from the previous week and a half, we were taking a stack that we had already validated on GH200 and now going to the rack level and saying, okay, well, let's scale up. We got one node, half rack, full rack, multi-rack, and we were able to really scale up quickly and very efficiently compared to what you'd have to do with if you never had a chance to look at these systems before.
Yeah, so the MLPerf sprint, as I call it, was very fun for us infrastructure, us performance nerds. And then the next phase is really trying to find that steady state. We were able to get the MLPerf cluster up to maybe somewhere in the realm of 50 to 75% of the cluster, but not the full delivery.
Correct.
So there was many, many months going forward of, okay, how do we not only keep the cluster healthy, but move nodes out that are unhealthy, replace them with new ones while delivering fresh ones. So there's a lot of challenges there because you run into this issue with NVL72. If a node dies on one of the racks or one of the nodes in the rack, how do we deal with that? And that's where working end-to-end with the researchers really comes into play. Right? If the researchers are running jobs across 64 of the GPUs in the rack, maybe we don't take out the rack and return it and swap it if two of the nodes are down.
Yeah. And this was all new learnings for everybody. How were these new NVLink trays going to fail? All this hardware will eventually fail, and learning to identify it as early as possible and restart your jobs is what we've been working on for the last 9 months, I think, nonstop. We've been able to feed back changes into your observability stack, into how you manage the cluster based on all of our issues that we've worked through together, and it's been a good, healthy working relationship.
Identifying that a node is bad is the easy part. It's usually what gets talked about, right? Is like, do you have all this testing, all this automation to identify a node that's bad? But what's really important in these like large-scale early adopter customers like IBM is to get the nodes back healthy as quickly as possible. Your cluster is at the scale where it's essentially entire data center, entire data halls. So all the racks we have there, whether we're working on getting them healthy or they're in production available for IBM, is all for you guys. So a big part of those early months was reducing that feedback loop. Okay, we know this node is bad. Is it the node? Is it the GPU tray? Is it the chip? Is it the InfiniBand NIC? Or, which is the new GB200 issue, is it something with the NVLink trays, the NVLink backplane? And we put a lot of work in with you guys to help figure out how we could narrow that down faster and, again, get those nodes back into the cluster. Because I think what we both agreed on, it's imperative to make sure that whatever nodes are available to the researchers are working at 100%. We know what job sizes you guys are running. We know that we don't want to risk introducing a slow node, slowing down your entire job. But work with you guys on how aggressively we want to ensure that every single node is burned in and healthy.
Yeah, and also the way that H100s failed is very different than the way GB200s failed. H100s, you'd be chasing what's the slow node causing your job to drag, whereas here it would cause it to a full crash, which is, I think, a little better as long as you can figure out which one of those nodes is causing it to. And I think we felt enough of those early pain points where the constant restart bug that we chased while we figured these things out was just one of those things that you only get to is if you're working fully together.
Yeah, I think during some of those months, I think NVIDIA was putting out a new version of Nickel, what seemed like every week. And every single week there was bug fix, like multi-node NVLink, something is wrong. I know there was that all-to-all hang that, again, only appeared at scale, and probably the only people at scale at that time was IBM and CoreWeave. So there's a lot of issues where you have to move really, really fast. Digging in a little bit to what it was like for the researchers to use this platform. One of the big changes from HGX, like node-based systems, to GB200 rack-based systems is that there's this new tier in the topology scheduling hierarchy. Using large-scale InfiniBand fabrics that CoreWeave builds, yes, there are super pods and there are leaf groups, and some people do optimize that for their topology or scheduling. Because there's no blocking, there's only a small latency hit, most people don't worry about that. 20 nodes anywhere in the cluster is the same as 20 nodes anywhere else in the cluster. That's mostly what people do. However, with GB200 and NVL72, any rack-based system, right, this is going to apply to the generations going forward, it's table stakes to introduce this topology or scheduling. So what do I mean by this? If there is an NVL72 system, I want to run a job across many, many racks, many multiples of nodes. However, I might want my first 8 ranks to all be on the same rack. So I could shard the model across those ranks, and they could use that extremely performant multi-node NVLink. But this isn't easy for researchers to grasp. Again, there's a lot of, I see 200 idle nodes, and my 100-node job isn't running. Is not starting. Again, because there is this new topology-aware constraint. So how was that looking with the researchers, and what were some things that we worked together on to solve this problem?
I think you've just covered it. It was one of those we just kept on experimenting, and we'd every once in a while we'd hit these weird, like, why is this not running, or why did this crash? And it was just we'd hit the right imbalance that caused a problem. And kind of working through with CoreWeave with NVIDIA, we went through and it took us a little bit, but we finally figured out what was the winning formula to get our models done at full performance speed.
Yeah, I think our GB200 scheduling recommendations doc is now written from the blood, sweat, and tears of all the problems that we dealt with together.
Oh my gosh, and we made, working with the researchers, we made some recommendations, and they might have decided to go slightly different, and that caused a little heartache in the beginning, and I think now they take our recommendations a lot more strongly now.
Yeah, I think anyone familiar with HPC is aware that every job is high priority.
Yes.
Right? But that makes it harder to schedule. So we had to work with setting some guidelines for the team. And again, that's where working with the customer's team, the customer's research team and the researchers directly really helps. Because CoreWeave, we don't know what job is high priority or low priority. So this is where partnerships really help build through that, solving that problem.
And being able to be open with you about, given the transparency of all of our training, made, I think, this process a lot simpler, that we could say what the jobs were, what we were attempting to do, because not every customer wants to share that information.
So we're talking about all these struggles, all these hardships that we had. The light at the end of the tunnel, the Granite 4.0 model family, which you've trained and released on the GB200 NVL72 cluster. I think the first in the world to train entirely on GB200, so congrats. Tell us about it. What are these models? What is Granite 4.0? How is it different?
So the initial release was at the beginning of October, where we released small, tiny, and micro. Small was 32B with 9 billion activated, tiny was 7B with 1 billion active, and micro was 3B. And then yesterday we also released an additional 2 models that we're calling nano, that are sub-billion parameter models, which have been very hot the last few weeks, that are specifically for tool calling and instruction following. And those are just 1 billion and 350 million parameter models. These aren't made to write prose in the style of Vito Corleone. These are meant to solve real HR problems, real specific task and domain issues for our enterprise customers. So you can utilize the 32B model to solve a more complex problem, and then call submodels to really optimize your costs. And honestly, I think that's really one of the things that is scaring customers right now, is they're seeing the cost to run an inference service at scale is immense. And on top of that, we've been really trying to be as transparent and open with our entire training process. As we talked before, everything that went into training the models is available in our model cards. And one of the nice things about working in this smaller model space is that customers can take them, they can modify them, they can fine-tune them to a domain or task-specific problem that they're working on.
Yeah, so you don't need the largest GB200 cluster in the world to use these models.
Correct. If you're training from scratch, they are fantastic and they shave months off these deliveries. But when you're fine-tuning, you can really use a much smaller compute resources to get them to where you need them to be. And honestly, how you get them into the hands of developers is making them that they can run on their MacBooks. The more we can try to get these models into the hands of a user, into a developer inside an enterprise or a programmer, the better for us and the more feedback we get. Honestly, some of my favorite feedback when we do these model releases is the long discussions in Hacker News or Local Llama on Reddit, where they're coming back, well, this is working, this is not. And that's all getting fed back into our training process.
Yeah, it's been the joy of open sourcing models. Right?
Yep.
The community really rallies around them, and you can start seeing really, really cool applications.
Yeah, and it was funny. I saw somebody posted a problem that they were running into, and I was going to go answer it, and I saw one of the researchers in charge of training the model had already answered it. So it's been a really fun, stressful, but fun project to work on together. And I think you've sensed the urgency on our side, given all the announcements this year in different size models, different toolings, techniques, novel architectures. When I first started in this space, you'd get one big announcement a year. And now we feel like we're getting an announcement every week.
It's the CoreWeave way, the CoreWeave pace, and we're excited to partner with IBM to experience some of that.
And speaking to the CoreWeave pace, when we first started looking at the possibility of partnering with you, we did some due diligence and talked to some of your current customers about their experiences with CoreWeave. And one of them mentioned, oh, Peter Solanke will be in your Slack channel helping you with your problems. And I said, okay. And that's been absolutely true. I don't know if he sleeps, but he has been, as you know, very involved in every time we've hit a new issue. He's been there with us. So.
Yeah. AGI is achieved when we have a Peter Solanke bot. You can't tell.
Yeah, there may be one already.
Maybe. Maybe that's the CoreWeave secret sauce. Right, so these models are released. They're out there to the public. How can I use them? How are they licensed? Where can I get my hands on them?
So right now, the easiest place to get them is right off of Hugging Face. It's been a very different way of working in IBM. The last few releases of Granite have been us on a Slack channel reviewing models before we release them to Hugging Face and not going through this long process. But they are available to be used with VLM, the Olama. We have MLX versions, so you can run them on your local MacBooks. We can take advantage of trying to bring the models as close to you and as easy to you as possible. We've made them Apache 2 licensed, so they're completely open source. And again, we're really driving this view of trying to make enterprises as comfortable with these models as possible. We were top 5 in the Stanford Transparency Index, and that really dives down into a lot of what we are willing to provide about our model.
That's great. I think we've seen enterprises be a little hesitant. These models are open source. People have coined the terms open weights because they don't actually know how these numbers got there in the model, and they don't want to open themselves up for risks. But you've shown there's a lot more that can be done than putting the weights online, and IBM is really moving in that direction.
And if you go see our model cards right now, we capture all the train data that goes into it, the raw scores that we get on these benchmarks, trying to make sure that the community sees that it's reproducible. We're really trying to be a partner to the community.
Yeah. It's one of the best parts of working at CoreWeave is being able to empower partners, really making strides in the industry like this. Brian, it's been great reminiscing about the last few months of our lives working on the project.
Thanks for having me.
Thanks everyone for watching this episode of AI Cloud Horizons. Stay tuned for next episodes where we'll talk with other pioneers in the AI space and talk about everything CoreWeave, the essential cloud for AI, is doing.